Hello guys, welcome to the another series of coding. Today we will solve Leetcode problem cousin in binary tree. So here given the root of binary tree with the unique values and values of different node of the tree x and y. Okay, value of different node of x and y. Return true if the node correspond to value x and y and in the tree are cousin, otherwise false. So basically there is a two condition here given, that a cousin will be a node that parent is different and the depth should be at same, depth or level should be a same. Basically you can say height of that node should be a same. Okay, suppose that here, let take this example. First root node was 1 and left child was 2 and right child was 3. So uh, the height of left child and right child and 2 and 3 are same, but parent is same, so this is not a cousin. Okay, so in this question they have asked about 4 and 3. We will let calculate the height of this 4 first. The height of 4 is 0, 1 and 2, right? So the height of this node is 3 is 0 and 2, so they are not cousins, right? The parent, they are not. The at most one condition is certifying that the parent of 4 is 2 and parent of 3 is 1, but they are not at the same depth or same level. Okay, so let me take into the demo board so get the further understanding. So let me change the pen. Okay, so here is a binary tree. So we first query is given that we have to find that this node and this node is cousin or not. So 3 and 4. Okay, and we have checked. Basically the parent of 3 and 4 is same. Okay, parent of 3 and 4 is same. So first condition dissatisfied and we will return false. Okay, we will return false. So now another query is given that what about 8 and 7. Okay, what about 8 and 7? So the about 8 and 7, the parent of 8 is 3, parent of 8 is 3. Okay, and parent of 7 is 4, so the parent is different. Okay, and they both are at the same levels. You can see, suppose that this is 0. Okay, and this is 1 and this is 2, so they are at the same level. So we can say these two nodes are cousins. Okay, what about 9? What about 9 if we say that? Okay, uh, if we say that 7 and 9 are the cousins, yeah, and they will certify this condition. They will certify these conditions. The parent of 9 is 3. Okay, and parent of 7 is 4, and they are at same level, so they are the cousins. So what about 9 and 3? And so what about 9 and 8? Okay, so the parent is same, so we will return false. Let me take one more example. Okay, suppose that here is 3, 4, 5 and 6, and the question is asking that tell that 6 and 5 is a cousin. So they are the parent, they have different parents. Okay, they have different parent. This having 4 parent and this is having 3 parent, but they are not at the same level. So they are not at the same level. Okay, so what the approach you will apply to tackle this problem? First we will make a function. Okay, first we will make a function, and that function will take and that function will take 3 parameter. First we will give a root. Okay, First we will give root, after that we will give depth. Okay, depth, the starting depth would be 0, depth would be 0, and after that it will, and we will give the parent, first, initially we will give none. Okay, and now we will if we will apply condition if that root dot value equal to x, or this x or y, if is satisfied, then it will see the depth of that and parent. Okay, and it will store in the separate variable. After that we will same we will calculate for y, and if root dot value satisfied to y, then it will store the parent and the depth of that value into a different variable, and at last we will return whether it is depth is same or not. Okay, and parent are different. Okay, if it satisfies the condition, we will return true, otherwise we will return false. So let's jump into coding and you will get the further understanding. Okay, so we will use recursion here. First we will make a helper function. Okay, helper function that we will call recursively, and this helper function will take a node. Okay, and root. Okay, let me write. Okay, no problem. Root, and then it will take as a depth, so we will give df, oh sorry, df, and another it will take a another parameter, it will take a parent. Okay, parent, and if if the root doesn't exist, then the answer would be 0, or it will return none. Okay, so if root doesn't exist, obviously answer would be a none, to return. Okay, return. After that, if the root exists, then we will see if root dot value equals to x or y, x or y, x or y. If the root value is x, then we will calculate the parent of x and depth of x. Okay, so we will make a variable self dot d. We will say d, equal to depth. Okay, after that we will update its parent also. We will make another variable par parent of, I will say a. Okay, that will look pretty efficient, because it will confuse the parent. Okay, parent parent equals, what the heck is this? Okay, a parent equal to uh, parent. If we certify that node root dot value equal to x, then it will its depth will become the depth of this. Okay, and parent will become a parent of this no x. Okay, and will it is stored in the variable. Else if it's at, if root dot value equal to y, the same logic will be for the y. Okay, same logic will be for y. After that, what we will do, we will recursively call, and we will keep adding the depth of the function. Okay, helper root, first we will call on the left subtree. You can choose any, you can go with the right subtree also, but I'm going to with the left subtree first. Left plus, okay, comma node, root. After that we will same apply to the right subtree. right side, and we will keep adding the depth, and it will become root. And after that we will call this function from outside, and we will give root, and initially we will give this 0 as a depth and parent as none. And after that we will return what we will return. First we will compare if self dot a first depth or equal to self dot depth of b. If the depth of a and b equal, then we will first condition satisfied. Okay, and another condition is parent should be different. Parent should be different. A parent, so parent not equal to, okay, not equal to self dot parent b. Answer spelled, I think. Okay, let me run this program first. Something went wrong. Oh, sorry. I not written the whole name. Same, I had committed mistake. Sorry for the typo. What happened here? Attribute has no B. Let me see. Oh, sorry. I commit a lot of typos. So forgive me, guys. Again, something went wrong. Self dot parent B, and what is that? B attribute object has no attribute B. Sorry guys, please forgive me for this silly mistakes. Okay, it's working. Let's see how much time it taking. It took 45 ms. It is pretty efficient than previous solution I have submitted. And thank you guys for watching.